Probability is countably subadditive. That is, for every sequence of events, A1 etc. Probability of union I from 1 to n A, probability of A1 plus etc. So ഞാനൊരു മോഡൽ ഞാൻ കാണിക്കാം, നിങ്ങൾക്ക് പെട്ടെന്ന് മനസ്സിലാവും. A1, this is A2, A3, A4, etc. A1, A2, A3, A4. What is A1 union A2 union A3 union A4? So that is actually union of A1 then A2 intersection A1 complement, then A3 intersection A1 and A2 complement, then A4 intersection A1 complement, A2 complement, A3 complement. So you can continue this procedure. So that is what is written here. A1 union A1 complement intersection A2, that is the red region. Then A1 complement A2 complement intersection A3, that is green region, etc. Okay, you can see that these are disjoint, these regions are disjoint, the different colored regions are disjoint. So you can add that probabilities. Okay, so if you take probability of union I from 1 to infinity AI, that will be equal to probability of A1 plus probability of A1 union A1 complement intersection A2 union A1 complement A2 complement intersection A3, etc. Since they are disjoint, you can add these probabilities: P of A1 plus P of A1 complement A2 plus P of A1 complement A2 complement A3, etc. So that is actually, but you know that probability of A1 is probability of A1 itself. Probability of A1 complement intersection A2. A1 complement intersection A2 is a subset of A2. A1 complement intersection A2, that is red region, is a subset of entire A2 region. Okay, so you can use the biggest probability, that is probability of A2. And A1 complement intersection A2 complement intersection A3 is subset of A3. So this probability is less than or equal to probability of A3. So you can write like this. Okay, so that's the general term. General expression you can write like this: probability of union I from 1 to infinity AI less than or equal to summation I from 1 to infinity P of AI. Okay, So that is one of the result. Next is now we do some problems. So first theoretical, regarding the theory, probability theory, the theoretical part we have almost done almost all theoretical works. Now we solve some problems. What is the probability that a leap year selected at random will contain 53 Sundays? Okay, what is the probability that a leap year selected at random will contain 53 Sundays? You know, in a leap year, we will have 52 weeks, 52 into 7, 360 days, that means 52 into 7 plus 2. Okay, so there shall be definitely 52 Sundays, and moreover there are 2 additional days. And what are the possibilities for that days? It may be either Sunday Monday, or Monday Tuesday, Tuesday Wednesday, Wednesday Thursday, Thursday Friday, then Friday Saturday, Saturday and Sunday. So these are the possibilities. 7 possibilities are there. So for these 2 days we have 7 possibilities. So any of this for example, in case 1 we have Sunday, and in case 7 we have Sunday, and in all other cases we don't have Sunday. So out of these 7 possibilities, we have 2 possibilities for having Sunday. So 2 out of 7. So that is the idea. So the probability of having 53 Sundays, 52 plus 1, that means 53 Sundays is 2 out of 7. Okay. Another example. 3 coins are tossed. What is the probability of getting all heads? Exactly 1 head, exactly 2 heads, at least 1 head, at least 2 heads, at most 1 head, at most 2 heads, no heads. So several questions are there. So what is the sample space? Sample space is HHH, HHT, HTH, THH, HTT, THT, TTH and TTT. So all head means we should get HHH. So that probability of that all heads will be 1 out of 8 possibilities. So that is 1 by h. Second case, probability of exactly 1 head. Okay. So there are 3 cases with 1 head. That is. No?
That's Swati or the class admitted.
Sania. വന്നിട്ടില്ലല്ലോ.
സർ അശ്വതി പെർമിഷൻ ചോദിക്കുന്നുണ്ട്.
ഇല്ല, എൻ്റെ കാണുന്നില്ല, അതാണ്. ഒന്നും കൂടി ക്ലോസ് ചെയ്തിട്ട് ഓക്കെ. So 1 head, there are 3 possibilities: HTT, THT, TTH. Okay. So so 3 out of H. Exactly 2 heads. That is, there are 3 possibilities: HT, HTH, THH. Next is at least 1 head. That means 7 possibilities are there. Okay, 7 by 8. At least 2 heads. At least 2 head. It can be 2 head or 3 head. So there are 4 possibilities. These are 4 by each. At most 1 head. At most 1 head means these are the 4 possibilities. 4 by each. Then at most 2 heads. That is, there are 7 possibilities. 7 by H. No head. No head means TTT. TTT. So 1 by H. So these are the probabilities. Now another question: what is the probability of getting a spade or an ace from a pack of cards? So there are 52 cards in a well shuffled pack. Okay. Out of these 52 cards, 4 different categories of cards are available. So one among the categories, spade. Spade had diamond and flower. So spade, spade means there are only 13 spades. Okay, but the possibility is there. It may be an ace. The card may be an ace, a spade or ace. So spade is 30. Number of spade is 30. 1 3. Number of ace is 4. But one of the ace is spade itself. So 30 plus 3. So that is 16 by 52. Okay, so that is the answer. Next question: a box contains 8 red, 3 white and 9 blue balls. Okay. If 3 balls are drawn at random, so we will uh, 8 white, 8 red, 3 white and 9 blue balls. Eight white, 8 red, then 3 blue. So we have to determine the probability that all 3 are blue. All 3 are blue. 2 are red and 1 is white. So we can select 3 balls from 9 blue balls in 9 C3 ways. Okay, 9 C3 ways. And the total we have 8 plus 9, 16 plus 4, 20 balls. So from 20 balls we can select 3 balls in 20 C3 ways. So number of favorable cases is 9 C3 and the number of total cases is 20 C3. So we can divide number of favorable case divided by number of total case, that is 9 C3 by 20 C3. After simplification you can see this is 7 by 9 5. Next is 2 red and 1 white. From 8 red balls we can select 2 red ball in 8 C2 ways and 1 white ball from 3 white ball in 3 C1 ways. So the number of favorable cases is 8 C2 into 3 C1. Total cases is 20 C3. So 8 C2 into 3 C1 divided by 20 C3, that equal to 4 by 9 5. Okay. Next is probability of at least 1 white, that is 1 minus P of A complement, that means 1 minus none is white. Okay. So if you remove white balls we will have 17 balls because we have 3 white balls. So number of favorable case for none of white is 17 C3. Okay. Total cases is 20 C3. So 1 minus 17 C3 by 20 C3. So that equal to 1 minus 34 by 57, that equal to 23 by 57. Next is probability of one of each color. So we will have 1 red, 1 white and 9 blue balls. So the number of favorable cases is 8 C1 into 3 C1 into 9 C1 divided by 20 C3, that equal to 18 into 3 into 9, that is 18 by 95. Okay. What is 8C NCX? What is NCX? NCX is nothing but n factorial by x factorial. NCR is equal to n factorial by r factorial into n minus r factorial. You have to this combination formula. NCR. That is the procedure. Next is another problem. What is the probability of getting 9 cards of the same suit in one hand at a game of bridge? Okay. So we should get 9 cards of same type. We know that there are 4 type of cards. 4 into 13. Okay. these are 4 type of cards. Four type of cards are there. In each set we have 13. Plus 13 plus 13 plus 13. Altogether we have 52. So if you select cards at random, we have to compute the probability that 9 same color. Okay. So what will be the remaining 4 other color? That means 52 minus 30. That means 39 out of 39. This is out of 13. So out of 13 we have 9 cards, and out of 39 we have 4 cards. So the number of favorable cases is 13C9 into 39C4. But we have 4 possibilities because that is the we have 4 type of cards. So 4 into, okay, 4 into, because we have 4 possibility due to 4 type of cards. Not color, card, same type card. Okay, so this is the number of favorable cases, that is 4 into 13C9 into 39C4 divided by total cases, that is 52C13. So this is the answer, probability, required probability. I think we have discussed all these. This is sigma algebra. We have already discussed all these things. Axiomatic definition. I think we have discussed this definition also. So I will review once again. Sample space, example. Sample space containing tossing a single die. That is, sample space is this one. Sample space of tossing a coin until we get a head. We will stop the experiment when we obtain a head. So this is the sample space. Now lifetime of a machine, 0 to infinity. Possible values are 0 to infinity. Event is a subset of sample space. Now what is field? What is field? If S is the sample space of random experiment, then the collection of all sets F is called a field or algebra if it satisfies these conditions. That is, F is non-empty. The elements of F are subsets of S. These are the important 2 conditions. One is, if A is member of F, then A complement is also a member of F. And if A is a member of F, and B is a member of F, then finite union, that is A union B, is also a member of union or intersection. Okay. So the speciality of field is this one. This is the differentiating criteria, finite union. So what is the definition of sigma field? Sigma field is referred with countable union. Okay. Let S be a non-empty set and F be the collection of all subsets of F. Then F is called a sigma field if F is non-empty. Tile elements of F are subsets of elements of F are subsets of F. ഈ രണ്ട് കണ്ടീഷനാണ് പ്രധാനപ്പെട്ടത്. എന്താണ്? If A belongs to F, then A complement belongs to F. അടുത്തത് the union of any countable collection of elements of F is an again element of F. That is, if AI belongs to F, I is equal to 1, 2, 3, etc. up to infinity, not N, up to infinity. Then union I from 1 to infinity, AI belongs to F. Okay. So, example, phi and whole space. That is a sigma field. Another sigma field is phi, not 0, is phi. Phi A complement S. Another is power set of S always form a power field. Okay. Another concept is measure. So using that concept we derived axiomatic definition. Okay. So this is the measure concept. So what is a measure? Measure is a real valued set function which is satisfy this property. Measure is a real valued set function. It's a set function. Okay. So which satisfy this property. Mu of union A1, A2, etc. will be sum of or mu of A1 plus mu of A2 plus etc. provided A1, A2, etc. are disjoint. So this property is called countability additive. So this property is used in axiomatic definition. So this is the formal definition. Let S be a sample space and B be a class of all events consisting of Borel field. Borel field means it is actually can be considered as sigma field. Okay. Then for each A belongs to B, we can find a real valued set function P of A known as probability for the occurrence of A if P of A satisfies the following three axioms. I think I have already given this definition in some previous classes. This is not euro sign, it is less than or equal to. So there are several printing mistakes in this book. Please ignore this type of printing mistake. This is actually 0 less than or equal to P of A less than or equal to 1. Then P of S equal to 1. Then if A1, A2, etc. not N, A infinity is an infinity sequence of elements of in B, then such that A intersection A equal to null set, then probability of union I from 1 to infinity A equal to summation I from 1 to infinity P of A. This is countable additivity property. So this is the definition of എനിക്ക് തോന്നുന്നത് ഞാനത് നിങ്ങൾക്ക് ഓൾറെഡി തന്നിട്ടുണ്ട് probability definition. ഇത് ഇന്നലെ എടുത്തത്. അപ്പോൾ ഞാനിവിടെ നിന്ന് എഴുതാം. പുസ്തകത്തിലുള്ള ഡെഫിനിഷനിൽ കൺഫ്യൂഷൻ ഒക്കെ ഉണ്ട്. ആക്സിമാറ്റിക് ഡെഫിനിഷൻ. അതിന് മുമ്പ് ലെറ്റ് if A belongs to script f, then 0 less than or equal to E of A less than or equal to 1. That is first definition. Next is E of S equal to 1. Third one is if തന്നിട്ടുണ്ട്. Okay, so this is the definition of axiomatic definition. ഇവിടെ ചില വലിയ മിസ്റ്റേക്കുകളുണ്ട്, അത് നിങ്ങൾ ഒഴിവാക്കാൻ വേണ്ടിയിട്ടാണ് ഞാൻ ഒന്നുകൂടി എഴുതിയത്. ഓക്കെ, തിയറംസ് ഓൾറെഡി നമ്മൾ ഡിസ്കസ് ചെയ്തു. ഇവിടെ ഒരു തിയറം ഉണ്ട്, പ്രോബബിലിറ്റി ഈസ് ഇൻഫിനിറ്റ്ലി അഡിറ്റീവ്. ദാറ്റ് ഈസ് E of A1 യൂണിയൻ A2 യൂണിയൻ എക്സ്ട്രാ AN വരെയുള്ള എടുക്കുന്നെങ്കിൽ ആ n വരെയുള്ള സമ്മാണ് നമ്മളിവിടെ ആഡ് ചെയ്യേണ്ടത്. ഇത്രേ ചെയ്യുന്നുള്ളൂ, നമ്മൾ ANൽ നിർത്തില്ല. E of A1 യൂണിയൻ A2 യൂണിയൻ A3 യൂണിയൻ എക്സെട്ര അങ്ങനെ പോകും. പിന്നെയുള്ളതെല്ലാം നമ്മൾ നൾ സെറ്റായിട്ട് എടുക്കും. n വരെയുള്ളത് ഒറിജിനൽ സെറ്റായിട്ട് എടുക്കും. കാരണം നമ്മുടെ ആക്സിയം 3ൽ ഇൻഫിനിറ്റി വരെ ഉണ്ട്. ബാക്കി വരുന്നതെല്ലാം എന്തായിട്ട് എടുക്കും? നൾ സെറ്റായിട്ട് എടുക്കും. അപ്പോൾ അതിവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ നമുക്ക് ഇങ്ങനെ കിട്ടും പി ഓഫ് എ ദാറ്റ് ഈക്വൽ ടു പി ഓഫ് എ വൺ പ്ലസ് പി ഓഫ് എ ടു പ്ലസ് പി ഓഫ് എ ത്രീ പ്ലസ് എക്സെട്ര പി ഓഫ് എ എൻ പ്ലസ് പി ഓഫ് ഇൻഫിനിറ്റി പ്ലസ് പി ഓഫ് ഇൻഫിനിറ്റി പ്ലസ് എക്സെട്ര സോറി പി ഓഫ് നൾ സെറ്റ് പ്ലസ് പി ഓഫ് നൾ സെറ്റ് പ്ലസ് എക്സെട്ര. നൾ സെറ്റിൻ്റെ പ്രോബബിലിറ്റി 0 ആണ്. അപ്പോൾ അതുകൊണ്ട് ഇവിടെ വരെയുള്ള ആഡ് ചെയ്താൽ മതി. അതുകൊണ്ട് നമുക്ക് ഇങ്ങനെ റൈറ്റ് സൈഡ് കിട്ടും. ലെഫ്റ്റ് സൈഡ് എയുടെ കൂടെ നൾ സെറ്റ് എടുത്താൽ യൂണിയൻ ആ സെറ്റ് തന്നെ എഴുതി. അപ്പോൾ അതുകൊണ്ട് ഇനി നൾ സെറ്റ് ഇല്ലാതെ ഇവിടെ എഴുതി. ഓക്കെ ഓക്കെ സോ ദിസ് ഈസ് ഫൈൻ. ഇപ്പോൾ കൗണ്ടബിളി ആണ് നമ്മൾ പറയുന്നതെങ്കിലും ഇത് ഫൈനൈറ്റ് കേസിന് ആപ്ലിക്കബിൾ ആണെന്ന് അർത്ഥം. മനസ്സിലായില്ലേ? കൗണ്ടബിൾ കേസ് മാത്രമല്ല ഫൈനൈറ്റ് കേസിന് ആപ്ലിക്കബിൾ ആണ്. സോ ദാറ്റ് ഈസ് ദ ഐഡിയ ഹിയർ. അപ്പോൾ ഫൈനൈറ്റ് കേസ് കൗണ്ടബിൾ കേസിൻ്റെ സ്പെഷ്യൽ കേസായിട്ട് ഇവിടെ ഉപയോഗിച്ചിരിക്കുകയാണ്. ഓക്കെ, ഇത് നമ്മൾ ഓൾറെഡി ഡിസ്കസ് ചെയ്തിട്ടുണ്ട്. അഡീഷൻ തിയറം, 3 events, ഇതൊക്കെ നമ്മൾ ഓൾറെഡി ഡിസ്കസ് ചെയ്തു. ഇനി നമ്മൾ വേറെ 1-2 കാര്യങ്ങൾ കൂടി. Probability in finite sample space 3 equally likely points. Suppose there are n sample points. For example, like എന്താണ് നമ്മുടെ ഡൈറ്റോസിങ് എക്സ്പെരിമെൻ്റ് പോലെ. ഓക്കെ, ഇങ്ങനെയാണെന്ന് വിചാരിക്കാം. എസ് ഈക്വൽ ടു 1 2 3 എക്സെട്ര 6. So P of E1 equal to P of E2 equal to P of E3 equal to P of En. ഇപ്പോൾ ഡൈറ്റോസിൻ എക്സ്പെരിമെൻറ്റ് എല്ലാത്തിൻ്റെയും ഫേസ് വാല്യൂവിന് സെയിം പ്രോബബിലിറ്റി ആണെങ്കിൽ P of 1 equal to 1/6, P of 2 equal to 1/6, etc. P of 6 equal to 1/6. സോ അതാണ് ഈക്വലി ലൈക്ലി എന്ന് പറഞ്ഞാൽ. ഓക്കെ, so each element will have same probability. If there are n elements, the probability will be 1/n. Okay, so that the total moreover they are disjoint. So this is the total probability 1/1 1/n plus 1/n plus extra 1/n, that is n/n, that equal to 1. Hello. കാറിലുണ്ട് 10 മിനിറ്റ് തരാം. കാർ so in the event A, if we have E1 equals to EM, then the probability will be add the probability corresponding to that elements. ഉദാഹരണത്തിന് suppose A is equal to set 1, 2, 3. Then probability of fail equal to 1 by 6 plus 1 by 6 plus 1 by 6. That's only. That equal to 3 by 6. Okay. M by n. So we can discuss these all problems in the next class.